Welcome to the section of debugging of your course Java development. This is the introduction to debugging. The Tech Skills is providing this course for you for free. All we want is to have your education and you helping us to grow. Please subscribe to our YouTube channel to help us to grow. Follow our Instagram, like this video, comment and share, because these actions will help us to make the YouTube algorithm really recommend our videos as the most preferable for debugging in Java. Welcome to the class. We're going to have an overview of debugging, debug Java code in IntelliJ. Let's go. This is going to be different. First we're going to have a conversation, then we're going to jump into our IDE. Developers write applications to solve problems in the real world. These applications are not perfect and sometimes they contain bugs, which are unexpected failures in the software when it's executing. It would be amazing if developers could write applications that could never contain a bug, but it's almost impossible that that happens, or that we have this case. The application scale gets more users, intensive data processing. If it's an application for the public, even if it's for private usage or any purpose, more features become part of the application, and these features may introduce new bugs. Sometimes we use third-party libraries, and the wrong usage of those libraries bring us some bugs, and these bugs need to be solved in order to have a good software developed and a good software in terms of performance. Fortunately, developers have a way to debug the applications, and the way that they debug is through a debugger. I want to tell you something that will be so interesting for you and worth. Running an application in debug mode makes it run slower than the normal, because the debugger makes an extra processing. Because of that, using debugger to make track of the problems related to threats can be challenging, since the time of the program differs from the time when it runs in the debug mode. Now we can go into the practice and see some interesting code and work on. Open your environment, and I'm opening mine. Well, I have here two classes, simple project with the main and with a manager class. Manager class has a field that's going to store the amount of string added, a string builder, a method to introduce info, which takes as a parameter and a string builder, which is sBuilder, and a string, which is s. Then we add this when we append the string into the string builder of this instance, and we add the amount of string that this instance has. Other method to get our string builder, which returns only a string builder. Okay, here on the main we have an instance of the manager and the string builder, and while our string builder length is less than 25, we are going to introduce t to the string builder system out to print the info of this string builder. Well, this is a simple project and will make you see more info. Let's run this program in the debug mode. Debug mode because we want to debug. Run it just to click here, simple like that. Or you can simply right click and debug. Don't worry about the exceptions, because this is not our goal for this class. We're going to talk about that later. You can see here connected to target VM the address of the target, the transport socket. When we talk about thread, a socket is created, and this socket is created to communicate with our application in order to the info about the states of the application be transferred to the debugger. After we finish with the execution of our program, this socket also finishes. It dies, it gets disconnected. We have here the source of these bugs, line 10, in our main.java file, then on line 8. Okay, so it started here. When we call it introduce.info, line 8 created this bug. Okay, well, now we have to see the bug in action and how we want to see what's going on in our app. We have to stop somewhere and analyze the change that happened. The parts where the program will stop are technically called breakpoints. How we want to see line 8, we have to add a breakpoint. How do? We simply click with the left button over the line that we want to examine. And here we have this red circle appears and all the line becomes red. I don't know what color your IDE is going to put, but in my case is red. Let's run it again, and here the application stopped. When our application reaches the breakpoint line, it automatically gets suspended. When the app gets suspended, the breakpoint line is not executed. Therefore, it's suspended before the line of code is executed. But that doesn't happen in all the cases. In this case, this line 8, which states this dot str builder that append s haven't been executed. Yes, we have info here saying s builder and s. S builder is to refer to our parameter, and empty strings means that the parameter that was passed, which is this one, strb, doesn't have any content inside. S, which is string, has a content t. Then we have str builder to refer to this variable here on this line. What is the content? Is initially empty. This line hasn't been executed, remember. And s is t. Our breakpoint is highlighted here on our IDE, and we have right now a check mark. This check mark is to say that our debugger is live, or is working, or is running right now. Now I want to show you this debug tab. This is where we're going to play most part of the time. Here we have tools for debugging. We can customize our layouts to have more tabs here, but what really matters right now are the tabs that are here. Watch doesn't matter for now, but let's leave. We have frames here. What frames have or do or are? Frame is the place where the execution stack trace is placed. So all the execution stack trace of your application is going to be placed here. And every time your application calls a method, that trace is going to be added to the stack. The first method that was called was the main. The main was called by the JVM we have in our stack. Then we say manager.introduce info. What this is going to do is to call a method, and this method is on the manager class. Here we have this dot string builder that append is one of the statements, but the method is introduce info. Here you can see introduce info. We have variables. I think you can see what they are. They are variables. Yes, are the variables known by the method which was called. We have here introduce info. This refers to the class where this method is in. Amount of string added. We have this variable string builder. Why do we have more option here? Because string builder is an instance of a class string builder. Yes, str builder is the name of the variable. This is the value. In this case we have the reference. This is the name of the variable, and this is the value. In this case is 0. String builder is going to give us more details here because these are the fields of the class in itself. String builder, we have value, which is the field that contains what contains our array of 16 positions. You can see here. Coder is a field. Also count is also a field of string builder. We don't care about string builder fields right now. All I want to show you is that we have these two fields in our class, and here they are. Parameters. sBuilder is a parameter, and here is denoted as P by IntelliJ. And we have S, which is a parameter that we can see here, and it is T for now. Then we have watches. We don't cover watches for now. Now it's time to play a little bit and control the flow of execution of our program. We have buttons here that are going to allow us to do so. So let's rerun this application and start seeing what they do. The first one is show execution point. What this is going to do is to simply show the current execution line of your program. You may be thinking that this is unnecessary, but it's necessary. Imagine if you are working here on a different file. For example, I'm on let me open something that doesn't really matter. For example, I'm on this file and I'm debugging, and I want to go back to where my code is currently at in the debug mode. I just click here and it takes me to that place. Do you see? You may need this feature. Then we have the step over. Let's click step over. Did you see what happened? This line was executed and it gets suspended on the next. Step over will step over the line. In other words, execute all the line. If the line has a function to be executed, that function will be executed and it won't show the result of statements of the function, and it won't go to show you the parts of the execution inside of that function. So what happens is that we're just going to execute and go to the next line, stop, before we execute. Simple, like that. We have the step into. Let me run this again and you're going to see the difference. But before we see the difference, let me tell you what happens when we step into. When we step into a line, if the line doesn't contain a function, it will behave exactly the same way as step over behaves. And if that line contains a function, the debugger will enter to the called function. In our case, we have the append function, okay? And it will stop on the first line of that function. Let's step into. You may be wondering why it doesn't get into the append method. The reason why that happens is because append is a method from Java. Is Java, yes. String builder is from Java. Is a method from Java, and the error probably is not in the append method. That's why it skips, because developers of this feature of debugger thought that the error will not be in a Java class or in a Java method, because those methods are pretty much unable to provide you error, since they are developed with more critical thinking, and they don't give, or more rigid, I can say, they don't give you space to have errors. That's why it really skips it, simply. But let's make something different right now to show you that it gets into that method, or it gets into any other method within the execution of that line. Let's simply change this, that string builder, to get string builder. Rerun it. Okay, now we're going to step into and see in action. Step into. Now we have these two options. We have to choose which one. Let's step into get string builder. Do you see what happens? Now it is inside of the get string builder method, and it stopped on the first line. Let's now step into this append method. Okay, debug, run it again, step into what? This append method. Now we can step, even if it's related to a Java method. Okay, did you see what happened? It stopped on the first line. Cool. We don't need to have any previous method to be able to step into. Let's say this dot string builder, leave how it was, and here is where the for step into comes in action. We will force the debugger to debug Java inbuilt methods. How are we going to do this for step into? And here it's happening. I didn't need to write something before here in order to get the opportunity to choose which one I want to step into. Yes, let's go and talk about this one right now. Stop and rerun. What step out does is to first run the method and return to the line where the method was called. But before we step out, let's step into and step out. Let's step into some more lines here. Okay, go back and we can now step out. I told you, run the method, so it's going to add this amount, 1 unit, and it's going to simply return to the line where the method was called. This introduce info was called. So let me step out. Here we have that method was called here, introduce info. It's happening. This is what debug allows us to do, and step out function allows us also to do. And we have drop frame. Drop frame is like fall back to a previous stack frame. Let's come out here. What I mean is like rewinding your program. But if you make some changes to places like databases, you won't be able to rewind the change. Global state variables, you won't be able to rewind. Only local variables are going to be reset. Let me go and travel a little bit, but before I travel, let me continue. Okay, and here you can drop the frame. Simply, local variables have been resetted. If they are local variables, make sure that they've been reset. We also have this one, which is run to cursor. Imagine if we had more lines of code here. We were debugging our code and we wanted to stop right here on the line 13. We could add breakpoint, but multiple breakpoints may be something that is going to give us too much effort, and we don't want to do that. So what happens is that if we run to cursor, we are on line 13 and we click here, we will simply be telling the debugger to take the execution until the line where the cursor is on. Being so, we won't have to declare many breakpoints on our application. But how we don't have any info to be executed here, we may say run to cursor, it won't do anything, so it will simply come out here and continue with the execution. Right here I can click here also and run to cursor. Did you see what happened? We are here. It ran to the line 9 where the cursor was. So this was your first lesson on debugging. Please follow us, help us growing. We need to grow. We're delivering this for free for you, and we want your support.